Okay. Well, did you get any prep work done?
Nope.
By that I
I was,
mean,
when I said I did chemistry the entire day, I literally did chemistry the entire day.
okay. I've definitely had days like that. Okay.
Okay, let's see what we're
Well,
working on.
basically what's going on here is now there's one of the sheets you want to go to that has a giant list of trigonometric identities that we're going to use to do this stuff, and we need to memorize a lot of them for the test. So,
Oh,
um,
joy!
now,
All right,
I mean, we
so
know we know a lot of the beginning ones already, like tangent x equals sine x over cosine x, right?
okay.
Like
Is
we
there any
know
reason?
that. Some of them are easy, some of them are a little more complicated, but it's really just to help you understand what things mean.
Okay.
Um, but yeah, it's a lot of algebra. Like we'll be given an equation and we have to manipulate it to prove that it's the same as something else. At least that's what the video was. So like he'll have an equation and he'll have like tangent x plus sine x equals 1 over cosine of x or something weird like that. And we have to
Okay.
prove that those are equal by manipulating with the identities. So like substituting tangent of x for sine of x over cosine of x.
Okay.
And then just like changing the equation around to make them look similar. Um, anyways, I didn't think it was that complicated so far.
Mm-hmm.
And then there's a PowerPoint that just discusses the difference between even and odd functions, which I don't exactly see any use for yet, so we'll have to see.
Okay.
Um, but your algebra is probably pretty good, right? It seems
Yeah.
like you know what you're doing with our other assignments, so I don't think that's going to be an issue. It's just um, being able to refer to this trigonometric identities page. So, do you have that open on your computer?
Which one is it?
So, week 10, uh, resources, and then trigonometric identities,
Oh, okay.
the page you're going to want to open. And that one's going to be really helpful.
Reciprocal
Like, I'm just
polarity.
leaving this tab open because I'm going to refer to it
Yep. Holy
throughout all
crap.
we do. So, it looks like a lot, but then you look into them and you're like, oh, well, that's easy. And some of them get more complicated toward the bottom, but we
Yeah,
don't
no
need
kidding.
to know all of them. For the test, we need to know all the one with the asterisks by it,
Oh.
which is a lot less.
Oh. Okay.
Yeah, a little bit less intimidating, right?
Yeah. Ah, jeez. Okay, I'll be right back. I
Okay.
Another thing that's been going on today is my bowels have been a little bit disturbed.
Acting up. Okay.
Okay.
No worries. Some of these definitely don't make sense,
Oh, yeah?
which is awesome.
Doesn't sound awesome.
Okay. Luckily, the things I am confused about are not on the quiz for today, so that's good.
Oh, cool.
Well, there's an algebraic simplification worksheet that I did not do because that looked like extra practice to me. Which, as good as it would be, I didn't have time, so I figured I'd skip that step because I can figure out algebra along the way. So yeah, the team discussion part of the GHOA assignment wanted us to start by talking about or checking our answers on that worksheet, but neither of us did it, so we'll move on.
Okay.
We got to open it up still. 6 and 7, hang on. Preparation assignment. I might have to open up the preparation assignment because I don't know what it's talking about there. Preparation. Okay. Yeah, let's go to that. I think this will be good to talk about these 4 questions.
All right.
So, preparation activities. Do you have that open?
Yeah.
Okay, so number 3 through 6, it says we should discuss our solutions. So on number 3, the first part is tangent x over secant x, right?
Yeah.
So it says use identities to simplify the following expression. Well, tangent x equals sine x over cosine x. And 1 over secant equals cosine of x, right?
Yeah.
So I think that's using algebra.
So that'd be sine of x.
So it would be sine of x over cosine of x times cosine of x. At which point we can just cancel both cosine of x's and we're left with sine of x.
Yeah.
Does that make sense?
Yeah, that's what I was saying before.
Okay, cool. Yep. So that's how we would do that one. Next. Let's see. Cotangent of x is what? 1 over cosine? No, 1 over tangent.
Cos.
Oh, it's also cosine over sine.
Yeah, so you could cross out the cosines. So you're left with 1 over sine of x. So you got sine of x plus 1 over sine of x, which
Wait, why did you cross out the cosine? Isn't it, wouldn't
So
that
isn't
turn into cosine squared over
yeah, you're right. You're right.
sine?
Yeah, it's
Cosine squared x over sine x.
cotangent is cosine over sine, right?
Cosine over sine, yeah.
Okay. Yeah, you're right. So, huh.
So, I mean, doing this in our head's probably a bad idea, but um, yeah, so we have cosine squared x over sine of x plus sine of x. Now we need a common denominator. So sine x is our denominator on the right. So we'll just multiply by sine of x over sine of x
Yeah.
on the left side there. So that we get
Sine of x,
sine squared x over
sine of x.
sine of x plus cosine squared of x over sine of x. Now we can add across. Sine squared of x plus cosine squared of x equals 1. That's one of the identities there too.
Oh, really?
Yep. So yeah, if you go to that trigonometric identities page, it's the first Pythagorean identity.
Oh, okay. So then it would just be 1 over sine of x, and that's just cosecant of x.
1 over, oh, you're right. I totally ditched that part of the equation in my head. Yeah, so 1 over sine of x, which is
Cosecant of x.
cosecant. Okay, that makes sense. Okay, and then we're done.
Okay.
Cool. So that's kind of making sense, which is good. Let's do this next one. Sine of negative x times cotangent of negative x.
So, oh,
I'm not exactly sure what to do here.
negative x.
So
Okay.
one of the identities does show that if there's a negative x, you can just put it in front of the sine or cosine or whatever. So yeah, one of the
Yeah.
identities is
Or,
sine of negative x equals negative sine of x. So you
yeah,
can just move the negative, basically.
yeah. And there's no, is there a cosine or secant in this at all? Okay, we're good
Well,
then.
cotangent.
I'm just pointing out with those even odd identities, there are two on there where it just change so like cosine of negative x is the same as cosine of x. And secant of
Oh,
negative x is just secant of x.
okay, that's weird.
Yeah. So I was just
I'm
making
glad
sure.
you caught that. Yeah, I would have done that wrong.
Okay, so right now we're at negative sine of x times negative cotangent of x. Or would that just be
Times.
subtracting?
So if it's a negative times a negative, then they're just positive, right?
Yeah. So
So you just ignore the x's.
cotangent is cosine over sine. So you just cross out the signs. You're just left with cosine of x.
Agreed. Cool. Yeah, I think you're right. All right. So far, so good. This guy. So cosine of negative x goes to cosine of x.
Yeah.
So that negative really doesn't mean anything. We just ignore it.
Yeah.
And this one's fun. He showed one similar to this in the video without that negative.
Okay.
And we actually have to multiply the right fraction by 1 plus cosine x over 1 plus cosine x, and multiply the left equation by 1 minus cosine x over 1 minus cosine x in order to get a common denominator. And then we can add them together and do all that fun stuff. But that's just busy work. I think we could figure that out.
Yeah.
So let's move on, I think,
Okay.
for the sake of time. Use the identities to express tangent x in terms of the sine function only. That's weird.
Yeah. I'm not sure what that's even
So
asking.
sine x over cosine x, but then what do you do with the cosine x? How do you get that to sine?
To express tangent of x in terms of sine function only. Okay. So that could be secant times something.
I'm really not sure how to do that.
There's too many of these.
Unless we just do sine over secant and call it good. But that's, I don't know.
Yeah. So, okay.
Or sine times secant is what I meant. Sine x secant.
Tangent equals sine over cosine. 1 over cosine of x is the same as
Secant of x.
secant of x.
So
that would
sine
be
x times secant of x
which that
is the same.
becomes something, maybe. I'm not sure.
Yeah, I don't know where to go from there, to be honest.
I don't know either.
Yeah, I don't see any way to get that back to sine. So, let's ignore that. It's not on the quiz, so.
All
right, let's look at 5, I guess. In the resources folder, you reviewed how to determine if a function was even, odd, or neither. I didn't see anything about neither, but okay. So, actually, I get it. Using the algebraic technique for determining even, odd, or neither, determine the following functions.
okay.
So cosine 2x over x. I am not... It didn't really talk about how to tell without graphing it. Like, except, okay, maybe this will help. So cosine of x and secant of x are both even. And then sine of x, cosecant of x, tangent x, and cotangent of x are all odd. Other than that, I'm not exactly sure what to do. I'm guessing just since it's in terms of cosine, it's going to follow that and it would be even.
Okay, and it's not.
It's not?
Yeah, it says that this one's odd.
Hmm. Yeah, I wish there were any amount of an explanation to tell us why.
Yeah.
Cosine 2x. That looks okay. When I graph it, it looks odd
Okay.
because of the rotational symmetry. So this is what I get. If you can see that.
Oh, okay.
So if there's rotational symmetry, it's odd. If there's vertical symmetry, it's even. I don't see any vertical symmetry there, but I do see rotational symmetry across the origin.
Okay. So what is rotational symmetry?
Um, just rotating across the origin.
Oh.
Like, yeah, I mean,
So like it never touches the origin?
no, just that it's symmetrical. So meaning like this versus this.
Okay.
It's symmetrical, but if you flip it, it's not, right?
Uh-huh.
If you flip it,
Okay.
it's not, but if you rotate it, it is.
Okay.
I don't know how else to describe that.
No, it's
Flipping it. Anyways, it's just good to. The PowerPoint goes through it, but not very thoroughly. It just states that, so I'm not questioning it really.
okay.
So rotational is odd, vertical symmetry is even.
All
When I
right.
graphed it, it did look like rotational symmetry, so I guess we're going with odd.
Okay.
And then sine t plus cosine t. Um, just going to plug that in to see what my calculator thinks of it.
Okay.
Um, hmm. I'm not sure, to be honest.
Well, the answer key, if this helps you out at all, answer key says neither.
Well, okay, because it just looks like a straight line that has a little bit of a diagonal to it, but
Uh-huh.
in the slides, the example on the even function is actually that's not a straight line. Hang on. None of these are a straight line. Never mind. So straight lines, I guess, don't qualify.
Okay.
And neither. Yeah, well, sweet. I'm guessing some of these will be on the homework and we can just learn them through the homework module.
Yeah, sounds good.
All right. I don't want to do this stuff, so let's pass.
Okay.
I will note that on the third part of 6,
Okay.
the secant squared x minus cotangent squared of x,
Yeah.
I would look at that normally and be like, I don't know what to do with that. But in his video, he would factor that. So he would go, secant. Hang on. Does that make sense? Yeah, like he factored that out to like secant of x minus cotangent of x in parentheses times secant of x minus cotangent of x, right? So he like reverse factored that. Or is that factoring?
That's still factoring.
Okay. Yeah, normally I wouldn't look for that, but that's how he did it. Okay. So extension problems. Let's run through maybe a couple of these.
All right.
So on the GHOA assignment, that first one says, as you learned in the preparation assignment, it only takes one case to prove something false. Show that the following equation is not an identity and discuss why. So I look at that and think, yeah, that looks like an identity. But I guess it's not. So what I did notice looking in the list of identities on the double angle identities, sine of 2x equals 2 sine x cosine x. So I think since sine of 2x equals that, it can't equal what it's showing here.
Yeah.
And that's one case, so it must be false.
Well, that's how I see it.
Okay. Well, yeah, I looked at, so number 2, this is where I was saying that it's confusing and that I don't know what to do with this, but so the first part is to find an equivalent algebraic expression for sine times inverse tangent of x. And, well, inverse tangent is going to be what? Cosine of x over sine of x. So it'll equal cosine of x, right? Because the sine of x will cancel. Or hang on, I don't.
No,
No, that doesn't work.
It doesn't work?
No, because the sine, the x part of the sine is inverse tangent of x. I didn't realize that before.
Oh, yeah.
Yeah, sine doesn't have an x. So I don't know what to do with that. I don't know how you get a triangle from that. So all of that means nothing to me. But I figure I'll learn this stuff in the module, so maybe we should just do the quiz. The quiz is easier than this stuff.
All right, I'm good with that.
Okay. I learned pretty well from those modules, actually.
Yeah.
When I get to look at something and it can tell me whether I'm right or wrong, it really helps me confirm, my understanding.
Yeah.
Okay. Well, I can write number 1. Simplify the following trig expressions. Okay, well, you might as well work on this, and I'll work on it, and we'll
Okay.
see what we get. This is looking pretty tricky, though. I hit a roadblock.
Yeah. Where are you at right now?
So I am at 1 minus 2 cosine x plus 1 over sine of x minus sine x cosine x. I don't know if you came across that.
So at the moment, I've already combined the two things together.
Yeah.
So I'm at sine of x squared plus 1 minus 2 cosine of x plus cosine of x squared all over 2 sine of x minus 2 sine of x cosine of x.
Hang on, is it when you do sine of x times sine of x, that becomes sine squared x, right?
Yeah.
Not sine x squared. Like the square goes on the sine, not on the x, right?
I
I
guess.
I think that's how we did it. I'm gonna check on his video really quick.
Yeah.
I'm pretty sure he did it that way every time. So
Yeah. Well, either or.
I came to that point though too. And then yeah, from watching his video, I found so there's the cosine squared x, and there's also a sine squared x in the top part of that equation.
Okay.
Well, you can combine that portion of it, and that equals 1.
Wait, really?
So cosine squared x plus sine squared x equals 1 from the Pythagorean identity. And so I just put a 1 in there, and then
Okay.
that's as far as I got. I'm stuck at that point. I don't
Okay.
know what to
So
do next.
now that's 2 minus 2 cosine x all over 2 sine of x minus 2 sine x cosine of x. So right now, I you can pull out a 2, like you can get rid of the 2's.
Mm,
So you would have 1 minus cosine x all over
does that
2.
help us though?
I'm possibly let me just like try and work through it.
Okay.
Cosine of x. Uh, come on, there's gotta be something.
Yeah, I didn't see anything this hairy in his examples.
Wait a sec. Oh, wait. Hold on. I might have something. All right, answer is cosecant of x.
How did you figure that?
Okay, so after you take out all the 2's, you're left with 1 minus cosine of x over sine of x minus sine of x times cosine of x. What you do is,
Well, hang on. Where did you get? There were no 2's on the bottom
yeah, there were.
in the
Oh,
denominator.
oh, crap. No, there weren't. Dang it.
I
Wait,
mean, sure, you can still factor out a 2 in the top, but you have to leave that in the top.
yeah, you do. Hold
Like
on.
2 times 1 minus cosine x.
2, 1 minus cosine x all over. All right, so now the closest that I've gotten is 2 over sine of x.
How did you simplify the rest of that?
So in the denominator, you factor out a sine of x, so that leaves
Mhm.
you with 1 minus cosine of x. And so you just uh, cross out the 1 minus cosine of x from the top and bottom. So you're left with 2 over sine of x.
Ah, brilliant. I like that. 2 over sine of x, which equals 2 cosecant x. Right?
Is that what it means?
Well, it can.
Oh,
Yeah. They're both true. I just think that it's more simplified if it's not in a fraction, right?
yeah.
So,
I just know that you could get anything out of 2 over sine of x. If it was 1 over sine of x, I could see it being cosecant. I just didn't know that you could make it 2 cosecant.
yeah. Because, yeah, I mean, just factor out the 2 from that fraction, and it would be 2 times 1 over
Okay.
sine of x, and then you just flip it, multiply it back on. It's the same thing, you know?
Okay, that makes
So,
sense. All right, cool.
awesome. Well, I'm glad you figured that out because that was going to drive me up the wall.
Yeah.
Cool. One complete. Actually, that was just 1A, huh?
Yeah.
Hopefully B is not as difficult. He seems to like to put difficult ones at the very beginning of his tests.
Yeah.
I don't know if you've noticed that, but I have.
Huh.
Okay, before you get too far, I'm going to say something.
Okay.
The second Pythagorean identity is 1 plus cotangent squared x equals cosecant squared of x. So if you just subtract the 1 over cosecant squared of x minus 1 equals cotangent squared x. So I think we can swap that right from the get-go.
Okay. So I think it might be cotangent of x.
So cotangent is cosine over sine, right?
Yeah.
Cotangent of x, agreed. Okay. I was just slower than you. But what's new?
Dude, you do a lot better at this stuff than I do.
Oh, I don't know about that. I'm just trying to make sense of things along the way and not rush through it so I don't have to study as much.
Yeah. So identities you have learned and the different strategies verify the following identities. Wait, verify?
Okay, so verify meaning prove that the left side equals the right side. So basically just simplify both sides until they look the same.
Oh, okay.
So it all looks like a big jumbled mess, but just simplify both sides until they look the same. Yeah.
Okay. So A checks out. 0 equals 0.
Okay. I'm just getting started on it, so you can move on to the next one.
Okay.
Okay, I agree. So another thing I should mention,
Okay.
um, on these ones where we verify, he
Mhm.
said don't move anything across the equal sign.
Oh, okay.
Yeah, so just simplify each side of the equal sign individually.
Okay.
Yeah, hopefully you didn't go too far.
No, no, I haven't. That actually, I think that makes things a little bit easier.
Yeah. This is hard.
All right, I got it.
Really?
Yeah. I gotta tell you though, it was not easy.
All right, walk me through what you did.
All right, so
Yeah, start with one side.
all right. So the original problem is 1 minus sine 2x over 1 minus cosecant of negative x
Right.
equals 1 plus sine of negative x over cosecant of x.
Mm-hmm.
So the first thing to do is switch
So
those
negative, right?
of, of negative x's.
Yeah.
So
So you have 1 minus sine squared x over 1 plus cosecant x on the one side, correct?
yeah,
Okay, I got there. And then on the other side, 1 minus sine x over cosecant x.
yeah.
Okay.
Okay.
What do you do
So
next?
the next thing you do is I 1 minus sine of 1 minus sine 2 of x.
Yeah.
You can factor that. So now you have parentheses 1 plus sine of x and a parentheses times 1 minus sine of x.
Hang on, tell me that again.
I so parentheses, beginning parentheses, 1 plus sine of x and a parentheses,
Oh, okay.
beginning parentheses, 1 minus sine of x.
Okay, so you factored it.
Yeah.
Okay.
So after that, I you do the cosecants. So cosecant is 1 over sine of x. So on the left-hand side, I you need to make it so that 1 plus 1 over sine of x comes together. So you have to do change 1 into sine of x over sine of x, and then add them. So that's going to be sine of x plus, or yeah, I sine of x plus 1 over sine of x. And all that is underneath your 1 plus sine x times 1 minus sine.
Oh, okay. Let me work through this for a second.
Okay.
So sine of x over sine of x plus cosecant turns into 1 over sine, right?
Yeah, 1 over sine of x.
Those cancel. You get 1 over sine of x. And that's in the denominator, right? Or 1 over sine of x plus 1. And that's your denominator.
Yeah, I think so. So it should look like sine of x times 1 plus sine of x times 1 minus sine of x all over 1 plus sine of x.
Hang on a second. Over 1. I did something weird.
Okay.
So your denominator is 1 plus sine of x?
It can either be that or sine of x plus 1.
Okay. So I have the sine of x over sine of x plus 1 over sine of x. I'm trying to remember what that turns into. Yeah, I'm just confused.
Okay, so
How do you get rid of the denominators there? I'm totally having a brain fart on this, but
okay, so let's go back a little bit. So you should have a
the 1 plus cosecant x.
okay,
So I get that. I get that the 1 can turn into sine of x over sine of x because that
yes,
equals 1. The
yes,
cosecant x part can turn into 1 over sine of x.
yes.
And I'm forgetting how to deal with that when you add those together.
So that's going to be sine of x plus 1 over sine of x.
Sine of x plus 1 over sine of x. Okay.
And so then you're going to flip that so that you'll have sine of x times your numerator. And then the denominator is going to be sine of x plus 1.
Okay. So now we have sine of x times 1 plus sine of x times 1 minus sine of x on the top.
Yes.
Okay, I'm following you now.
Okay. And all of that is going to be over sine of x plus 1.
Okay, that makes sense.
So now still dealing with the left side.
Sine of x plus 1s can be canceled, right?
Yes. The sine of x plus 1 or 1 plus sine of x
Yeah.
doesn't really matter. You can cross those out. So
Yeah.
you're left with sine of x times 1 minus sine of x, and then you distribute the sine of x. So you're left with sine of x minus sine squared of x.
Okay.
So that's pretty much all you need to do for that. And then the right side's a lot easier. So you have your cosecant of x.
Mm-hmm.
that changes to 1 over sine of x. You
Yeah.
flip it, and then you distribute that sine of x into your numerator. So you're left with sine of x minus sine squared of x.
Oh, that makes sense.
And so now they're equal.
Holy crap.
Yeah, that one wasn't easy.
Man, I can't believe you did that without watching the videos.
Well, algebra is kind of my thing, I guess.
That's awesome.
As
I
long
would
as
have
I know,
sat here and stared at this for the rest of the night.
as long as I know what I'm looking for.
Yeah. Whew. All right. Well, cool. I'm glad you knew what to do there.
Me too.
Well, that was almost less terrible than I wanted it to be.
Well, hey, at least we got done before 10.
Yeah,
That
that's a
doesn't always.
plus. Yeah. Okay. All right. Well, I'll get this stuff turned in, and you have a good rest of the week.
All right, you too, man.
Thanks for your help on this. Once again, you're a wizard. You are an algebra wizard.
I just wish this stuff was only algebra.
Yeah. Well, a lot of it will be.
Well, that's good.
Okay, well, sounds good. You have a good rest of the night.
Yep, you too. See ya.
Okay, see you, Tyler.
See ya.